Time. Wow, what a concept. We all know what time is, but if I ask you to define it right now, none of you would be able to define it on the spot. At least you will not be able to give a clear definition of time. Because time has so much to include and so many mysteries that it all cannot be included in one definition. Let's take a look at what we've been teaching our kids. In our textbooks, we see time as an observation of cycles of the world, or duration between two events. But is time really governed by these random two events or random cycles of the world? Does it not have a definition of its own? Well, that is the mystery, the inner mystery that we have in time. Let's look at history. The concept of time has been evolving as long as humans have been. With a simple sundial that our ancestors used to measure time, to the most complex atomic watches that we still wear in our wrist watches today. The atomic watch is so many times more accurate and complicated than the sundial, but it is useful and it measures time. The most accurate atomic watch can measure time accurate up to a quadrillionth of a second. That is really unbelievable in the advancement of science and technology. But what about time, the concept of time? Has it been evolving as well? Yes, it has. Before the time of Newton, around the time of Newton, time used to be thought of as a very simple concept. No one ever questioned it. Whatever goes in my wristwatch, whatever is moving, that is time. Whatever is being measured by my watch, that is time. But later on, we found out that this did not make sense and this was not correct. The events that occurred in our daily lives were not thought to be influencing the movement of time. But now we know something else. We knew this because of this great scientist over here, Albert Einstein, a curious mind who found out an alternate theory or concept of time which was really mind-blowing and a big step in the field of physics. He defined time in such a way that it changed the concept of time for us, for all of us. Time was thought to be a very stagnant concept that always moves about without respect to other events that are happening along with it. But he defined it in such a way that we found out that time was really influenced by the events that happened in our lives. So what he found out was really groundbreaking. He found out that time had dilations and it could be diluted according to the shape of the universe. He found out that the universe was actually a fabric that is made up of space and time. And because of it, we found out that what we call space is imaginary time and what we call time is actually imaginary space. So they coexist with each other into a fabric that makes up our whole universe. The space-time fabric, hence, is a really complicated topic because it changed how we saw time overall and how we perceived the concept of time. Time could be diluted and changed according to the events that happened here, and time could be diluted. But later on, what really happened will fascinate you. But before that, an example of the twin paradox, which is very well known in the scientific community as well among laymen. So, what the twin paradox says is actually it gives an example of a set of twins. Could be any kind of twins, but for this purpose we'll be using identical twins because they are said to be the closest to the human clones till date. So what this experiment or this theory does is it takes a set of twins and sends one of them to space, moving at a very high velocity near to the speed of light, and one stays back on Earth. Poor little twin. So what happens to the twin when they come back after 10 years to Earth is that we'll find a difference in them. We'll find that the twin that stayed in Earth is actually older than the twin that went to space because time was moving at a different pace, added a layer of confusion and a problem to understanding time. We see that the twin has aged differently compared to the twin on Earth because time for that twin, he or she, was moving near to the speed of light and time was moving at a different rate, at a slower rate near to the speed of light. Now till here there was no problem. to understanding time. Okay, we can understand this at some level. But another really drastically confusing thing happened when Albert Einstein came up with his general theory of relativity. The general theory of relativity suggests that the larger objects in the universe is able to curve this space-time fabric that makes up our whole universe. It curves the space-time in the fourth dimension that we call to be time. So what this essentially does is it adds a layer of confusion and a layer of complexity in the concept of time. Because now we found out that the rockets that are satellites orbiting Earth are actually moving at a different rate from an inertial point of observance. So what that means is that if you go and revolve around Earth with a satellite or any object that is revolving the Earth, time will move faster for you. This added a layer of complexity in the concept of time and how the physicists and scientists perceive time. Now, till here, we can explain what happens in the space. But this really cannot be applied in deep space. When we talk about deep space, all this crashes, this theory crashes. So there's essentially two parts of this concept. But what happens later on in the quantum scale is this theory falls apart again. We return back to the age of Newton, when we thought of time as a linear thing, where there was no gravitational time dilation. What the general theory of relativity suggested is that this gravitational field that we can feel right now, that we're living in, is itself space-time. So, deep space could be visualized in such a way. But when we come to the quantum scale, we see that it is eligible for space-time curvature, similar to the case of general theory of relativity. But we do not observe that. And till date, no scientist has found out a proper reason for why it does not bend space-time, why it does not curve it. This is the problem of understanding time, and till date, no theory or no scientist has successfully combined these two theories. Why do we need these two theories to understand physics? Why is there no theory of everything, or a sort of theory of everything that surrounds us and time itself? Well, the string theory, to some extent, is trying to solve this problem by combining both these theories into a unified theory. But till date it is not successful, but there are hopes of combining these two theories to explain this problem of understanding time. But till then, ladies and gentlemen, welcome to the problem of understanding